And I'll be talking about writing an LL1 grammar from the textbook. So basically, there's two problems that can show up when you're trying to write an LL1 grammar. And so, just real quick, LL1 refers to a uh, predictive recursive parser, and so that LL1, the one refers to the amount of lines that the parser can, the amount of additional lines that the parser can see in order to predict um, what will happen next. And so since there's one, it can only see one line in the future. And so that restriction brings about two possible problems, which are left recursion and common prefixes. Left recursion is basically, if you look on the second line there, ID list prefix arrow, ID list prefix comma ID. ID list prefix shows up both on the left side of that arrow and the right side of that arrow. And so this is confusing to the parser because it's the same exact thing, so it tries to do the same exact thing, and it doesn't have an additional piece of information to predict what's going to happen next with. And so a way to solve this is just to prevent that exact occurrence from happening. So here, as you can see, you can kind of change up the order in order that different things are on either side of the arrow, and so that allows the parser to continue along and put everything in its proper place without getting stymied. It can also get caught by common prefixes, where if you see the two places that ID appears, they're in the same spot to like directly to the right of the arrow, two statements in a row. And so this causes the same problem as left recursion. The parser gets confused because they're two of the same values following up after each other, and it's unable to continue the recursion. So to solve this, again, you can just not have common prefixes occur. You can sort of refactor the way that you write the code so that there's a different prefix on the right side of the arrow every time, and therefore the parser will be able to continue on without any problems. Now, another problem that prevents some languages from being truly universally possible to write an LL1 grammar with is something ambiguous like dangling else statements. So if you look at this example, there's two if statements and one else statement. And if you go by the indentation, that else statement would be associated with the first if statement. However, unless this is a language like Python, indentation doesn't really matter. And so in a lot of languages, that else would apply to the last open if statement, which would be the second if statement. So if this is possible in a programming language, then it would screw up your LL1 grammar because the predictive parser won't be able to either won't be able to parse it properly or will do something that the programmer doesn't expect. So one way that languages can counteract that is eliminate the possibility of dangling else statements. So here, as you can see in Pascal, they require an end statement for every if-else block. And so if you go through the first if statement and the second if statement, and then it says end, and so that ends that second if block. And so then after that, the else statement is applying to that first if statement. So again, some languages can't universally be used because they allow for that dangling else statement. So languages can make it more feasible to implement an LL1 recursive parser by including more strict rules like that in order to make it universally possible.